On a stormy night, have you ever looked up at the sky and found yourself captivated by lightning bolts slicing through the pitch-black sky, with thunder roaring as if nature itself were performing a majestic symphony? What are those flashes of light, and why do they appear in such a spectacular way? Today, let's step into the mysterious world of lightning, a natural phenomenon that is both awe-inspiring and terrifying, yet irresistibly fascinating. Along the way, you'll also discover an invention that changed how humans interact with this powerful force, the lightning rod. And of course, the intriguing stories surrounding it might just surprise you. Lightning, simply put, is a powerful electrical discharge that occurs in the atmosphere, typically between thunderclouds or between clouds and the ground. When a large amount of electrical charge builds up in the sky, with negative charges accumulating at the base of the cloud and positive charges on the ground or in other cloud layers, the resulting voltage difference becomes too great to sustain. The outcome? A dazzling bolt of lightning is unleashed, ripping across the sky like an arrow of light. The formation of lightning begins with thunderclouds. As warm, moist air rises and encounters colder altitudes, it condenses into tiny water droplets or even ice crystals. Amidst this turbulent activity, particles of ice and water collide repeatedly, causing a separation of electric charges. The upper part of the cloud becomes positively charged, while the lower part becomes negatively charged. And just like that, a massive electrical generator forms right above our heads. When the negative charge at the cloud base becomes strong enough, it begins to seek a pathway toward a positively charged area, usually the ground or the top of a tall object like a tree. A channel of ionized air forms, and once the connection is complete, a powerful electric current, what we know as lightning, is discharged. Fast, fierce, and incredibly dangerous. The path lightning follows often emerges during stormy weather, when humidity in the air is high. Moisture, or rainwater, is an excellent conductor of electricity, making it an ideal pathway for lightning to travel. Now we understand that lightning is essentially a giant electric discharge, formed either between clouds or between clouds and the ground. But have you ever wondered, with all the vast empty land on Earth, why doesn't lightning strike open plains or empty fields more often? Why does it seem to target people, animals, treetops, rooftops, and our electronic devices? To answer that question, we need to explore the lightning rod, also known as a lightning arrestor, to better understand not only how lightning works, but also how this invention helps protect us from it. The lightning rod was a groundbreaking invention by Benjamin Franklin in the 18th century. This device was designed to safely channel lightning into the ground, protecting buildings and structures from potential damage. The story behind Franklin's invention is both fascinating and legendary, and it has become one of the most iconic tales in the history of science. Here's how the story goes. In the mid-18th century, humanity still did not truly understand the nature of lightning. People only knew it as a powerful and dangerous natural phenomenon, but there was no concrete scientific explanation for it. European scientists had begun studying electricity and speculated that lightning might be a form of it. However, no one had been able to prove this theory, until an American scientist named Benjamin Franklin entered the scene. Benjamin Franklin was not only one of the founding fathers of the United States, but also a curious and inventive scientist. During the 1740s, Franklin conducted numerous experiments with electricity. He discovered that electricity could travel through conductors and be blocked by insulators. One of his most groundbreaking hypotheses was that lightning was actually a form of electricity. And if this were true, it might be possible for humans to learn how to control it. In 1752, Franklin decided to conduct a dangerous yet revolutionary experiment to prove his theory. He believed that if he could draw lightning from the sky into a conductor, it would exhibit the same properties as the electricity he had studied. Instead of relying on complex scientific instruments, Franklin chose a simple yet daring method. He would fly a kite during a thunderstorm. The kite was made of silk, a material both lightweight and strong enough to withstand the wind. He attached a metal key to the end of the kite string and used a length of silk string as insulation, allowing him to hold the kite without receiving a direct electric shock. On a windy, rainy summer day, Franklin and his son, William Franklin, took the kite out to an open field. The sky was dark and filled with the rumble of thunder and flashes of lightning. Despite the apparent danger, Franklin went ahead with the experiment. He released the kite into the storm clouds, hoping that the electrical charge from the clouds would travel down through the kite string. After a tense period of waiting, Franklin noticed that the string began to stand upright and stiffen, as if being pulled by a powerful force. This was the sign he had been hoping for. Electricity from the clouds had entered the kite string. Then, as he brought his hand close to the key, small sparks jumped from it. This was clear evidence of electricity. When Franklin saw the sparks emitted from the key, he knew he had succeeded. His experiment had proven that lightning was indeed a form of electricity. This was a groundbreaking discovery. Not only did it solve the mystery of lightning, but it also paved the way for future inventions and applications related to electricity. Thanks to Franklin's experiment, humanity began to realize that it was possible to harness and control the power of lightning to protect lives and structures. This understanding led to the invention of the lightning rod, a simple yet incredibly effective device used to safeguard buildings from lightning damage. The lightning rod operates based on a straightforward principle. When lightning strikes an area, the rod attracts the electrical discharge and channels it safely into the ground through a metal conductor, preventing it from damaging the building. The reason lightning rods are able to attract lightning is because they meet most of the conditions that lightning tends to favor. These conditions include 1. Height and proximity. Taller objects are closer to the electrically charged clouds, which increases their chances of being struck. 2. Shape. Pointed objects generate stronger electric fields concentrated at their tips, making them more likely targets for lightning strikes. 3. Conductivity. Materials that conduct electricity well provide an ideal pathway for lightning to travel. 4. Moisture. Wet environments conduct electricity better, which is why thunderstorms and rain create the perfect setting for lightning to form. So, to return to the earlier question, why does lightning so often strike people, animals, treetops, rooftops, and human-made objects instead of open ground? The answer lies in the fact that these targets better fulfill the conditions lightning tends to favor, as we discussed earlier. However, this doesn't mean that lightning only strikes these things. In reality, it does strike open ground quite frequently, but such instances often go unnoticed because they rarely cause obvious damage. Similarly, while lightning rods are designed to attract lightning, and in most cases they do, it doesn't mean lightning will always strike the rod. Occasionally, a bolt might defy expectations, veering off course and hitting something else nearby. That's why lightning rods are not a complete defense against lightning, but rather a tool to minimize the damage it can cause. Therefore, it's important not to underestimate the power of nature. Even with lightning protection in place, we should still take storms seriously. Nature is complex and doesn't always behave according to human expectations, just like in a game where unexpected things can happen. So when a thunderstorm approaches, the safest thing to do is stay indoors, keep away from windows, and avoid using electrical devices. And one more important thing to remember, during a thunderstorm or heavy rain with strong winds, never take shelter under a large tree. A tall tree acts very much like a giant lightning rod, making it an ideal target for a strike. If you're standing underneath it, you could be in serious danger if the current from a lightning strike travels through the tree and into the ground. So, if we shouldn't take shelter under a tree during a storm, what should we do when caught outside in heavy rain and thunder? That's actually a great question. Here's the answer. In such a situation, you should look for a safe shelter immediately. If you're outdoors, try to find the nearest building to go inside. If there's no building nearby, look for a low-lying area that's lower than the surrounding terrain, but be careful not to choose a place where water might collect and cause flooding. Most importantly, avoid high or open areas at all costs. And with that, we've reached the end of this video. Thank you so much for watching.